Hello, welcome to Tech Talk Episode 4. Where in the world is Router Sandiego? And all I can think of is that song. I'm Ryan Bowman, joined with...
I'm Brian East.
And yes, together we are part of the data team here at Connect Us. So we're going to get into today addressing, right? We're going to get into all kinds of IP addressing. We are not going to dive into IPv6 today. We are just going to talk more about dynamic, static, some of the differences there, and how internet traffic gets to its homes. So yeah, let's dive in here, and we'll kick it off. So let me share my screen. Look at this. All right, here we go. So anytime we're talking addressing, obviously we need somewhere to send it. So welcome neighborhood. Here we go. Isn't that beautiful? That's a really cool neighborhood, isn't it?
I think it's kind of scary.
Okay.
If I walked into a neighborhood that had those color houses, I would wonder if like somebody slipped hallucinogens.
So the third house, the greenhouse there, though, it has a satellite. I mean, it's like, super exciting. The others just have weird looking tall tower antenna things. So, all right, moving on. Let's just scoot down here. So, like, I always love to reference IP addressing and how data moves across the internet, no different than our homes. Right? We're very used to addresses with our homes, right? I live at a certain address, and that's how the mailman gets to my house every day and delivers mail to me, right? So think of your data traffic almost as mail. Don't really think about it as much as email, but think about it as your data bits and bytes are just flowing around the internet, and they need to know where to go, right? So in a typical address scheme for a home, right? We're all going to be on one side, and I love even numbers. That's my OCD coming out there. So we've got 100, 102, 104, and 106, right? Pretty simple. When the mailman, when the mail lady gets your mail and you live at 102 Main Street, such and such, town and city and or state and zip code, that's where they go, right? So that totally makes sense. And we have one very happy mailman. I mean, he's just delighted. He gets his mail, he delivers it on time, everything's perfect. So that's kind of what we would look at, and we're going to talk about what this looks like from a static and dynamic IP address, right? So we're going to go one more screen further. So this setup here is almost static addressing, right? So every time you assign a static IP, and we're speaking a lot about cellular devices. So in cellular devices, a static IP address is assigned to one mobile number or one SIM card, right? So you have one router with one SIM card with one mobile number and one unrestricted static IP address. That's the address that goes out. So what that means is every time an application is sending data to 100 Main Street, it gets there every time. The mailman delivers it to there. There's no ifs, ands, or buts about that, right? So that's kind of more of a reference here of what static looks like. But here's what happens when we add dynamic, which is typically the default from most of the wireless carriers, right? So if we pick that one house out that was over there, and it was 100 Main Street, well, what if it was also 102 Main Street? And what if it was also 104 Main Street? And what if it was also 106 Main Street, right?
Now, it's not going to be all of those at the same time.
It will not.
Right.
Nope. But yeah, so one time it gets on the internet and it's 100, and the next time it jumps on the internet, it's 102, and the next time 104. You could see how that could be very complicated to deliver data packets to that device. Now what happens is when they're using a dynamic IP, which is pretty typical out there, it will leverage one of those addresses every time it connects to the internet, because ultimately no one's remoting into most of the devices that are out in the internet. So the application itself is talking to, like, let's say you go to Google and search for cheese or whatever, right? There's an application there that's happening and talking. It doesn't need a static IP address to bring back that data and show you pictures of awesome cheese, which is delicious, just saying. So the problem is if you had an application where you wanted to remote into that router and actually get to that router, you would have a problem. you'd be more like this mailman who's like, what is happening? This is crazy. Sweating, trying to figure out where to deliver it to. Do I go to that house? Do I go to the other house? What was it yesterday? What was it today? Right? There's a complete breakdown of communication at that point because we don't understand that. So dynamic IP addressing is fantastic, especially for those who just want to go out and surf on the internet. It's fantastic. It's not a problem. But when you're talking about an application, I always like to use a remote camera connected to a router out in the field. There's a lot of times the camera application or you yourself want to remote into that router and see the camera feed. In order to do that, most of the time, you're going to need a static IP address.
And
what's that?
When you're running VPNs, like an IPsec tunnel or DMVPN.
Yep. VPNs are. Yeah. So those applications, that's perfect, Brian. Actually, is and you have one of these that you're just working on today. I saw an email, but being able to keep a VPN up from a cellular modem to a firewall or a router appliance, right? And we're just bringing in the internet connectivity from the cellular modem to be able to hold that VPN up, right? At that point, most of the time, that modem needs to have a static IP. We need to know where we're going, point to point, end to end, so we can make sure it's delivering that data to the proper place. So hopefully that helps. Brian, I am going to bring up another house. Oh, it's the one with the satellite. Sweet. Sorry.
Dish Network.
There we go. So you can speak a little bit to that crazy 166 address up there. How about it?
Sounds good. All right. So how do you read IP addresses, right? It's got what's called 4 octet. An octet refers to the number of bits per little grouping, right? So 166 is the first octet, 231 is the second, so forth and so on. And let's just say that if you want to conceptualize what does all that mean? What with that? Think of an envelope, right? So when you're writing a mom, and she lives at 102 Main Street in Fort Worth, you type in, Grandma East, 102 Main Street, Fort Worth, Texas. You're going to put a zip code in there. Let's just kind of ignore that for now. So the way you read an IP address is the same way, just backwards. So that first octet, 166, that is all of the home addresses that live in Texas. Right? So that's the last piece, right? Fort Worth, Texas. And then that 231, that says, all right, well, this is Fort Worth. And then all the addresses that can be in Fort Worth, which is a part of Texas, right? Obviously, in Texas, there's a lot more home addresses than there are in Fort Worth. But then we get to the third octet, and it gets a little even more slimmed down. That 165, that's all the houses that are on Main Street, right? Not a whole lot, right? And then that 92, that's your house number. That's the 102 for Main Street right there. That says that's exactly it. So when you're reading these IP addresses, that 92 is the 102 for the physical address. The 165 is Main Street. The 231 is Fort Worth, and the 166 is Texas, right? And then there's net masks that we can go over that another time, but that kind of tells you how many houses are allowed to be on that street, how many streets are allowed to be in that city, and so forth and so on. Hope that makes sense. That's, I think, the easiest way to relate IP addressing to just common vernacular. Back to you, Ryan.
Yeah, no, that's perfect. And I mean, that's what we wanted to really relay in this particular message is it's not a whole lot different than the addressing we live at in the real world, right? I think everyone watches Neo in the Matrix and thinks all the zeros and ones and it's all crazy. And a lot of the typical understanding and the path to get traffic from one place to another, it pretty much mimics and duplicates everything we're doing in the regular world. So it's not, when we hear IP addressing, I think sometimes folks get intimidated. They don't understand what that really means. They just know to put that feature on, or this is how much it costs, or not necessarily why we need static IP addressing or dynamic IP addressing, or we can add another one and talk about natted IP addressing, right? But at the end of the day,
and you can take the analogy a little bit further, right? What is DNS? DNS is essentially a DNS server says, all right, well, if you're trying to get from here to here, like if I live at 102 Main Street and Ryan lives at another address, I don't have to walk my letter all the way there. I have a mailman take it to post office.
Yep.
Now the post office knows post office to send it to, and so it says, all right, well, okay, so Ryan's in Harrisburg, Pennsylvania, so we're going to send this to another post office in Chicago. And then Chicago says, all right, well, I know the next one. It's actually going to go straight from Chicago to Harrisburg. And then the postman at Harrisburg says, all right, well, I know where this house is. I'm going to take it there. And that's what DNS servers do on the World Wide Web. Everyone's most famous, popular DNS servers are 8.8.8.8 and 8.8.4.4, and those are Google's DNS servers. And so Google pretty much knows everyone everywhere. And so but there's also sub DNS servers that live. There's an entire network of DNS servers worldwide, and think of them as post offices that take from your house to one post office to the next post office to the next post office to Ryan's house.
Yeah. Yeah, and DNS stands for domain name server, correct?
Yeah.
If I recall back to my A+ IT days, but I mean, it's just translating. You type in google.com, but what happens in the background is it just goes to 8.8.8.8, right? Like that's what's actually happening in the background. And so the really cool thing about that is if you compare that to post offices and stuff, it would be like if your postman was super, super sharp and smart, and sometimes you didn't even need to write the address on. Like you just wrote Ryan Bowman's house and they got it to me, right? That would be super cool. But that's kind of what the DNS servers are doing in the background. So, because a long time ago, when the internet was first created and DNS started to come about, they realized people don't love trying to remember all these numbers like 8.8.8.8. Like that's not something you would want to go put in your address bar every day, or whatever your IP address would be for whatever, right? It's the same idea when you're driving to someone's house. You don't get in your car with your family and say, we're going to 104 East Main Street, Fort Worth, Texas, otherwise known as Uncle Brian's house, right? Like you wouldn't say the address, you would just say we're going to Uncle Brian's, right? I mean, you wouldn't be like, hey kids, let's go to 323 South Benton Street, right? Like that just wouldn't make sense. So yeah, that's kind of what DNS is doing, and it's making it very much, very friendly for us out in the internet to be able to just type what we need to. So, not sure about tech today. I don't think we have any tech. So yeah, we'll catch you. This is a shortened version today. We're kind of like flying through some stuff. It's pretty darn awesome. The sun's coming out here in Northeast. I'm in Pennsylvania, and so we're gonna let you slide today and let you think about IP addressing. So thanks for tuning in. Thanks for checking out the video, and have an amazing day.
Stay metal.
There you go.